So let's look at another example. Take a quick look at it. You have a force, you have a pin connection and a roller connection, and we have 2 points here. Right here, this point D, we'll call this C, that's B, and we like A over here. There's a distributed load, boom, bunch of arrows pointing down. 0.5 kip per foot would be what that is. That's a 5 kip kilopounds, right? You have some corresponding distances between each one of them. Ooh. We're also going to have a distance right there, a distance here, and a distance here. And the question is, what's the loading on the beam? No, given the loading on the beam, my bad, what are the infernal forces at point C? That's where we want to figure it out. So let's attach some numbers to this thing. Solution, imaginary cut, right? Let's figure out how to get it done in this case, right? So first thing that we like to do is do our little FBD for the whole system, and we know that you have 5 kip, right? And then working with this 6 on 6, 12, we know that that would be acting at the point C, right? And this would be 0.5 times 6, which would give us 3 kip, right? And then we would assume that there would be some reactive forces, and we can just say, let's treat both of them as going upwards to resist it. And because it's a pin connection, you'd have a component over there, so you'd have AX and AY. Remember, these are both forces, and you'd have some FBY, which is a normal force right there, right? Summing the forces in X gives you 0, so we'd say FAX equals 0. And then we could say, let's see what's a simple equation that we could use in this case, and say, well, let's take the sum of the moments about B. In this instance, sum of the moments about B. Could have some of the moments about A also, right? Would I cancel out both of these two? But let's do some of the moments about, let's do both ways, right? So some of the moments about B, you would say FAY would be times this total distance, which is 6 times 4, 24, minus, and this would be 3 times 6, 6, 6, 18. 3 times 6 is 18. And we would also then say 5 times 6, right? Oop, I made a mistake there. That should have been a plus. Would be equal to 0. So we'll say FAY, can this be seen clearly? Would be equal to, drum roll, 5.75 kip, right? So let's move this away onto another screen. Let's keep this here and expand it a bit, right? So if all we wanted to do next was solve for BY, do we really need BY? Let's do it. So if you have for the whole body, some of the forces in the Y direction, you would have 3 plus 5 minus 5.75 should be equal to by, and that would give us what? 2.25 by, and this is in kip, right? So let's do the free body diagram for the AC section. I'm kind of jumping around, but let's say we start there. That's 1, 2, 3. Oop, that'd be 4, and this right here would be 5, right? So for 6, we're going to sum the forces. We're going to look at the free body diagram for the AC section, which is this section right here. And what we would see there is our AY. We would see the distributed force acting at a point a little bit distant away from C, and again at C. Let's say if this is 3 and we know this is 5.75, we would assume then that there would be the shear force VC reacting downwards. There's a normal force, and then there's going to be some kind of, we can only assume looking at that like that there would have to be some moment going upwards like that, right? So let me just move this over. I'll just keep that there so it's on screen a bit more. If we do that equilibrium, or the equations of equilibrium, assuming everything is going to be 0, it's a stable body because this is statics. Sum Fx, right? The shear force VC or NC, whichever one you'd call it, to be equal to 0. Sum the forces in y direction, right? And you'd get 5.75 minus 3 would be equal to VC, or let's say minus VC is equal to 0. This is 5.75. So VC would be equal to, drum roll please, what's VC equal to? 3 minus 5, 2.75 kip, right? Everybody got that? So next thing there now is summing come across here. If we sum the moments and we choose to decide about A, right? Remember A was the endpoint, right? We sum the moments about A. We would then have what forces would we have on this diagram? And we're using A right there. Let me just do this bit. Right there, you have A. You have this component. You also have the shear force component plus the reaction component, MC, right? So 3 times this distance, we can just call that -3 times 3, -2.75 times or multiplied by 6 plus MC would give us a nice 0. So from that we can say that MC would be equal to 25 not 2.5 but 25.5 kip feet. It's like totally messy, and I apologize for this. This is like a messy solution. So in review, we have 1, we have 2, we did 3, 4, 5, 6, and this was 6 also, right?